Okay, welcome back everybody. We are starting a new topic today, and this is going to be very different from everything that came before. I would say that last week marked the point in the course where the course became a little bit easier. Maybe you agree, maybe you don't agree. There was still math last week, but the math was maybe a little bit less difficult. There was what you had to do math-wise last week was divide by 2 sometimes for half-life equations, and maybe add some numbers up for the nuclear decay equations. To me, that's a little bit easier. This week there's going to be even less math. There is a little bit of math, but not much. Most of it involves counting to the number 4, which I think everyone here can do. But it is going to be much different than what came before. So what we are going to talk about today is something called organic chemistry. And this video is going to just be a brief introduction into what organic chemistry is, and just give you a general idea of the types of things that we're going to talk about. So there's not a lot of information in this video, but there is some. First thing that I want you to do is write all of this information down on a sheet of paper, because you're going to need to refer to it in the upcoming videos. Not for this video, but for almost all of the other videos that come up for this week, you're going to need to refer to this, or at least, if you don't want to refer to this, you're going to have to memorize it. Okay, so here's a bit of a review. If I pointed to that solid line right there, or that solid line right there, or any of those solid lines, and asked you what kind of bond we are looking at there, you can pause the video and think about that. We've discussed this much earlier in the course. This is called a covalent bond. That means the H and the carbon, the hydrogen and the carbon are sharing 2 electrons. That's what a covalent bond is. A lot of times this is called a single covalent bond. Then if I asked you what kind of bond is shown here, you can pause the video and think about that if you want. This is also a covalent bond. Informally, this is called a double covalent bond. And you can probably guess that this is called a triple covalent bond. And the only reason I'm showing you this, we have covered this earlier in the course, the only reason I'm showing this to you now is because we are going to deal a lot with these types of drawings, and we are going to deal a lot with covalent bonds in the upcoming videos. Alright, so this collection of lectures is on organic chemistry. In fact, the rest of the course is on organic chemistry. So the rest of the course is going to be very different from what came before. What does organic mean? Well, we're not talking about the Whole Foods definition where they were nice to the chicken before they killed it, and so you have to pay 3 times the price for your chicken. Organic in chemistry means something else. What it means is you are talking about molecules that have carbon in them. So organic chemistry is the study of molecules that have carbon in them, and in particular carbon with covalent bonds, which we were talking about on the previous slide. Organic chemistry is the study of molecules with carbon covalently bonded to things, to other atoms. Usually, so you have to have carbon atoms in an organic molecule. That's not the only thing you can have. You can have other types of atoms. Usually you have a lot of hydrogen atoms in organic molecules. You don't necessarily have to, but usually you do. You can also have oxygen, nitrogen, phosphorus. A handful of other types of atoms often show up in organic molecules as well. Not all of the periodic table shows up in organic molecules, but these are the most common ones in addition to carbon. Like I said before, organic molecules primarily have covalent bonds, not ionic bonds, so covalent means that they're sharing electrons. Usually, organic molecules are not very water soluble. In other words, organic molecules, as a general rule, don't dissolve very easily in water. But almost all of the important molecules in your body, aside from water, are organic molecules. And because you are mostly made of water, those organic molecules have to dissolve at least a little bit in water. So this is just kind of generally true, but it's not completely true. Inorganic chemistry is the study of everything else in chemistry. So if you were to break chemistry into categories, which gets done, there is organic chemistry, which we are about to talk about, and I said that's the study of molecules with carbon in them. And then there's everything else. Everything else is called inorganic chemistry, which just means not organic chemistry. We have been doing inorganic chemistry for most of this course, and I will be perfectly blunt, it is mostly boring. Sodium chloride is an inorganic molecule. No carbons there. It's pretty boring. This is an editorial comment before we get to the actual meat of the next video. There are many different organic molecules. There are zillions of organic molecules. Even though there are many of them, you actually don't get to use very much of the periodic table. You have to use carbon, you use a lot of hydrogen, and maybe kind of that's about the extent of the periodic table that you actually use. Those are the most common types of atoms that show up in organic molecules. So the question is, how can you make zillions of organic molecules if you only can play with a handful of different types of atoms, and you always have to use at least some carbon? What makes them different from each other, what makes the zillion different organic molecules different from each other, is how the atoms are attached. So even though you only can play with a tiny fraction of the periodic table, there are many, many different ways that you can attach those small numbers of different types of atoms to each other to make zillions of different types of molecules. The idea here is that different types of attachments give your molecules different features. I will point out that most modern medicines, almost all of them that I can think of, are organic molecules, and there are many different medicines, right? And so the primary thing that makes different medicines different from each other is the way that those atoms are attached to each other. There's usually carbon, hydrogen, maybe some oxygen, maybe some nitrogen, and a few other exotic things, and we have all sorts of different medicines. And the thing that makes the different medicines different from each other is the way that you're going to attach these atoms to each other. Different attachments give you different features, give you different medicines, give you different whatever. What we're going to focus on in this lecture is we're going to focus on describing different attachments in organic molecules to each other. We're going to talk about molecule A, and we're going to say, oh, the attachments are in a certain way. Molecule B, the atoms are attached in a different way. And this is just to drive the point home. These are a bunch of Lego bricks connected to each other, and the question is, are the Lego stacks identical to each other? It's pretty clear that they are not. This one over here is a tower. This one is like a little staircase, and this one is a two-way staircase. But if you notice, they all have, I believe, 7 little Lego bricks. 1, 2, 3, 4, 5, 6, 7. They all have 7. And so I am only playing with one type of brick, and I'm pretending that it's a carbon atom. You can see that I can get different features out by attaching those little Lego bricks in different ways. If I attach them this way, I get a tower. If I attach them this way, I get a staircase. If I attach them in the third way, I get a two-way staircase. So you can see, even if you only have one type of atom to play with, if you can attach it in different ways, you can get different features out. And that's the essence of what we are going to talk about in the upcoming videos. So that's it for this video, believe it or not. The primary thing that I want you to know is what organic chemistry is. See you in the next video.
Where to